Alright, so this last thing is just going to kind of put everything together. So we want to sketch a graph. So hopefully on your Chromebooks they have loaded the calculators, but if not, it's okay. You'll be fine with that one right now. So we're just going to sketch the graph. So if you do have a calculator, if you want to follow along, in y1, you're going to make sure you put your equation here. So x cubed minus 4x plus 1. And then I always just keep a 0 in y2. So x cubed minus 4x plus 1, and then we're going to graph those. So it does just say a sketch of the graph. Okay, so just sketch this graph. So something like that. Okay. Before I answer any of the questions, I'm going to find all the points that are going to need to help me. So I'm going to find, I know it's going to ask about maximum also, so I'm going to find this point right here. So I know that's a maximum. So just a reminder on the calculator, to get the maximum, you're going to go to second, trace, and you're going to go down to number 4, which is maximum. Now when you're doing max and min, it's going to say left bound. So the point you're trying to find is here. You got to put it on the left side of that. You're going to hit enter. And then you got to put it says right bound, so you got to put it on the right side. You're going to hit enter. Then it's going to say guess, and you're going to have to hit enter again. So, and you might want to make a little note, but we're going to be rounding everything to 3 decimal places. That's what they use on the AP Calculus exam. So this year will just help you kind of get used to that. So 3 decimal places. So that says negative 1.155 and then 4.079. So that's what that order pair is there. All right, next I'm going to go ahead and get this minimum point down here. So I'm going to go to second, trace, minimum. And it's going to say left bound. So now we're trying to find this minimum. So this is the point we're trying to find. I'm going to put it to the left of that. Hit enter. Then it says right bound. Put it to the right. Hit enter. It says guess. You're going to hit enter again. So that point gives us 1.155. And then the y value is negative 2.079. Okay. Other points that I'm going to need, because it's going to ask us about positive and negative, are the places where it's going to cross this x-axis. So those are called zeros. Because I'm going to go back to my y equals. Because I put 0 in my y equals, I can just find where these intersect that red line, or they intersect the x-axis. So I'm going to do second trace intersect. And I'm going to move it close to the first one, just so it'll. And then this one, you don't have to do anything special. Just move it close, and then you just hit enter 3 times. So the intersection there is negative 2.115. So then I'm going to find the next one here. I'm going to do second trace intersect. I'm going to move it close to that second one. I'm going to hit enter 3 times. And that gives us 0.254. And then this last point here, I'm going to do second trace intersect. Move it close to the point, and then you're going to hit enter 3 times. That gives us 1.861. And now I'm just going to not need the calculator anymore. That'll helps me get organized. So this is what part A said. Part A said for you to just sketch the graph. So here's a graph, and I have all the numbers that I'm going to need on there. Okay, so part B says label the extrema. So we know extrema is max or min, and we want to round to 3 decimal places. Tell if each extrema is absolute or local. So remember, local just means it changes directions. And another word for local is relative. You might see that instead. And then absolute means it has to be the absolute highest or absolute lowest point. So if we go through our graph, here we are increasing. Then we're going to change to decreasing. So because this point right here changes from increasing to decreasing, we know that that has to be a max. Now, Just because it's changing directions means that it's going to be a local max. The reason it's not going to be an absolute max is because this is not the absolute highest point. The graph actually keeps going here, okay? So for part B, I'm just going to draw arrows. So this point right here is going to be a local max, okay? Local or relative is not going to be absolute because it's not the absolute highest point. And if you remember, for max and min, we're going to use the y value. So we're going to say at y equals, that y value there is that 4.079. So we have a local max at y equals 4.079. All right, so we keep going, we're decreasing, then we increase again. So that means this point over here has to be a minimum. Now to figure out if it's local or absolute, well, this is not the absolute lowest point because it keeps going down forever. So this is just going to be a local min. For max and min, it's the only time we're going to use those y values, but our y value here is at negative 2.079. Okay. Part C wants us to figure out where this, or for what intervals of x is f of x increasing. Okay, so remember when you're doing increasing and decreasing, you're going from left to right. So just write increasing here. If you go from left to right, from here, you're increasing, then you decrease, then you're going to increase again. So all those places where I put those lines were increasing. Because we're using x values, let's go ahead and write negative infinity and positive infinity here so that we will know that we have to use those. So this goes, starts here, so starts on the far left of the graph and goes all the way up to my x value of negative 1.155. So my first increase in interval is going to be from negative infinity to negative 1.155. Remember, you have to use parentheses and then make sure you're always using x values. Now, there's another place, so we're going to put union. It also increases starting here and going up forever. So starts increasing back at this x value of 1.155, and then it's going to increase the rest of the graph, so we're going to use that infinity. Okay, so that's where it's going to increase. All right, part D wants to know for what intervals is it decreasing. Well, you already figured out where it's increasing, so the decreasing is going to be the part that we didn't use here. So let me make a different design here. So that's the decreasing part. We're using the x value. So the x value where it starts is the negative 1.155. X value where it ends is the positive 1.155. So that's going to be the only place where it decreases. All right, part E wants to know, is it continuous? So take your pen or pencil, and from your left to your right, do we ever have to pick up our pen or pencil? No. So it is continuous. All right, then it says, is it bounded? All right, bounded, remember you're going to draw the line above and below to see if it's going to cross. So if I was to draw this line here, because this has an arrow, it would cross. If I draw it below, it would cross. So because it's going to cross above and below, that means it is not bounded. All right, then we're looking at part F. So what intervals is the graph of f of x positive? Okay, remember, positive means above the x-axis, okay? So above the x-axis would be, hard to draw, but I'm going to have all this is above the x-axis. All that's going to be my positive. Now remember, you're using your x values for your intervals and you're using parentheses. So we're starting at this x value that I had wrote here. So negative 2.115 all the way to this 0.254. Then we have another spot, so we have a union. Then we have our 1.861. Then it keeps being positive for the rest of the graph, so we're going to use that infinity. So that's where it's going to be positive. And then finally, for part G, it wants to know where the graph is negative. So remember, graph is negative when we're below the x-axis. So we're talking about these two sections. Okay, so this is negative, this whole part over here, so we're going to use that negative infinity. It stops being negative at the negative 2.115. We have more than one spot, so we're going to put union. And then we're going to go this little section here. So from our 0.254 all the way to our 1.861. Okay, so I really like this example because it's all one graph and it shows you how you can see your max and mins, where things are increasing and decreasing, if it's continuous or bounded, positive or negative. So these are very important properties of functions that we'll be looking at all year. So just being able to see them in one place is very helpful.